right, today what we're going to do is we're going to finish up applying properties of positive and negative exponents. Yesterday we learned about zero, and we also learned about negative exponents. Today we're going to look at scientific notation. All right. Question: why do we study scientific notation? Like, who cares? Okay, scientists do, and you do see it in science. But why would they have it as a state standard? Why do they feel it's important? Yes?
So we don't have to write out huge numbers?
Correct. So we don't have to write out huge numbers. We can shorten them up a little bit. That's correct. Okay, why else do you think they would think it's important that you know how to do that? Because you're all not going to be scientists someday, so who cares? Where do we see stuff like this? We do. We see, national debt, right? We see money. Where we multiply really large numbers together. Or exponents. Right. Newspapers, right? You see it in newspapers. You see it in magazines. Okay, when we grab our math magazine, every time we take a test, we're exposed to really large numbers, and they have it in scientific notation. If you don't understand some concept of scientific notation, you feel almost ignorant because you don't really know what they're talking about, and we don't want you to feel that way. Okay? So at least you have an idea of what's really going on. So scientific notation. This is a way to write really large numbers in a shorter way, and it's in this form. So it's a number, which is n, times 10 to the x power. So it's kind of in that form. And you've had this before in science, hadn't you? Mm-hmm. Okay. So this should be either really easy for you, or if you never understood it in science, hopefully you get it today. And you're going to see it again. It's not like, oh, I'm done with 9th grade science, no big deal, I'll never see it again. You will. You'll see it all the way through, and even into college if you choose to go to college. Okay. So let's take a look at this. We want the decimal behind the first non-zero digit. In other words, we want it behind the first number that's not a zero. Okay, what's the first number? The first number is 4. So I'm going to go 4 point. So I'm going to put it behind there. And then I'm going to put all the other stuff. 2, 5, 9. I don't need to put all the zeros behind there. They're kind of assumed. Okay. And then I'm going to go times 10, and it's always times 10. And you always use an x. There's not going to be a variable there. Okay? And now the number that goes above the 10 is how many places you move that decimal. Okay? So right now the decimal is behind this 0 right here. So I moved it 1, 2, 3, 4, 5, 6, 7, right? So I'm going to put a 7 up here, and I'm done. That's it. All the exponent does above the 10 tells you how many places you move that decimal. And I like to do those little loopy things, because that helps me count. Okay? Let's keep going. Let's look at this one. What's the first non-zero number? 2. So I'm going to go 2 points. And then I put 7, 6, 5, okay, and then times 10, because it's always that, right? And then the decimals, if it doesn't appear, it's always at the end. Okay, so it's right here, and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8. And if you wanted to check this, you could. Because if it's a positive number, I'm going to take that decimal and I'm going to move it to the right. I'm going to make it a bigger number. And you could always plug it in your calculator and it would always give you the answer. So you always check your answer with your calculator. Questions? Okay, let's look at this one. Now, is this a really, really big number? Super, super small. So you'll notice it's quite a bit different than 2, isn't it? Right, so I'm going to set it up kind of the same way. The first non-zero number is 5. So I'm going to go 5 times, oops, 5 point, I've got to add other stuff on there. 5.74 times 10. It's always times 10. Now, because it's a really, really small number, the number up in above the 10 is going to be a negative. Okay, that's what makes it really small, is that negative. Think of the number line. I'm going negative on the number line to the left. Okay, and so I moved it from here to 1, 2, 3, 4, 5. So it's negative 5. So I could check it. I could take it. It's behind the 5 and it's negative, so I'm going to go to the left and I do my little loopy things and I'd be good to go. Any questions on this so far? Okay, let's look at this one. What's the first non-zero digit? 4. So it's going to be 4.86 times 10. Okay, now it's a super, super small number, right? So my exponent's going to be negative. Okay, let's count and do our loopies. Ready? 1, 2, 3, 4. So it's a 4. I just do the little loopy things. You don't have to, but if you're getting it wrong, you should. Questions? Something you don't understand? Okay, let's keep going. Standard notation. It's just a way to make a number that's in scientific notation in a longer form. So let's take a look at this first problem. Okay, it's in scientific notation, isn't it? So what I'm going to do is I'm going to take this decimal, and because it's a positive 7, I'm going to move it to the right, because I'm going to make it bigger. Because if it's positive, it's going to get bigger. So I write 2.0075, and I do my loopy things. So 1, 2, 3, 4, 5, 6, 7. Okay, and what do I do in those spaces? I'm going to add my zeros. So this ends up being 2007500, and I just put in my commas. So I've got 20 what? How do I read that? 20 million? 75,000, right? Yep. And you need to have commas. Every 3, remember, from right to left with the commas. Okay, let's keep going. Okay, so my exponent is a 5, so I'm going to go to the left or the right? I'm going to go right because I'm going to make it bigger. Right? So I'm going to write this down. 1, 2, 3, 4, 5. Now what? Add a 0. So then I write down all my numbers and I put in my commas. Oops. 702,340. We okay? Students have trouble which way to put the decimal. If you think, well, I'm getting a bigger number, so I'm going to move to the right, it makes it easier. All right, let's take a look at this one. Now it's got a negative exponent, so what am I going to do? I'm going to go to the left. Okay, so 3.096. Here's my decimal, so I'm going to move it 1, 2, 3, 4, 5, 6. Here's my decimal, and what am I going to do with those spots? I'm going to put zeros in. Thank you. 1, 2, 3, 4, 5 zeros, right? So it's going to be point, 0 point, or point 0, 0, 0, 0, 0, 3, 0, 9, 6. And if you're going to do the little loopy things like I did and you have two decimals, then you need to rewrite your answer. And a lot of times what they'll do is they'll put a 0 in front. So just be aware that it's the same thing. All right, let's take a look at the next one. It's a negative or a positive exponent. So I'm going to move to the left or the right. To the left because it's a negative and I'm making it smaller. That's why you move to the left. Okay? So I've got 1.685 and I'm going to move 1, 2, 3, 4. And I always make my last decimal bigger so I know that that's the one I want. So I get 0.000165. That's my number. Question. Okay. All right. This is where kids mess up, and this is where I get a little crabby because I'll have kids just look at it and go, well, that number's bigger. And I'll say, why? And you'll go, I don't know. I get it in my head. Okay? Remember, I can't cut your head open. Even if I wanted to, I don't have the degree to do that. So I can't cut your head open. What? Yeah, I'd have to be a medical person. Oh, yeah, a neurologist. And then I could, but I don't have that degree. So what you want to do is you want to make sure that they're on equal playing fields to be able to compare them. So I'm going to leave the first number alone and I'm going to change the second number. Okay? So the second number is to the 5th. So I'm going to move that decimal 5 spots to the right because it's getting bigger. So I'm going to move it 1, 2, 3, 4, 5 and I'm going to put the decimal there. So the number is 403.400.1. The other one, I'm going to line up underneath it, and I'm going to line up the decimal. Remember in elementary school, when you added and subtracted, you have to line up the decimal? Okay, so I'm going to line it up. If you line up the decimals, this immediately oh my gosh, I know how to do that. So I go from left to right. My 4s are the same, my 0's the same. These are not the same. Okay, so which one's bigger? The left one or the right one? The left one is bigger, and so that's when you put in your inequality symbol. So you need to show your work. You need to put them on the same playing field, line them up, and then make your comparison. Don't just put in a symbol going, hey, there you go, get it in my head. Questions? All right, let's go to the next one. All right, on this one, I've got a negative exponent, so how do I move that decimal? To the left, okay? So 3.309, I go 3 to the left. So 1, 2, 3. So I get 0.003309. There's that one. Now the other one I line up, 0.003309. Okay? And I go from left to right. 0 in front of it. Okay? The first zeros, they're the same. The decimals line up. I got a 0, a 0, a 3, a 3, a 0, a 9. What do I know about these? They're equal. Yep. Questions on this? Okay. That is it. That's it for today. Questions? Okay.